Why do iron rust slowly, but fireworks, the one you know as Vanguard, explode instantly? This is as a result of the topic we'll be dishing out today succinctly, and which is what we call chemical kinetics. But before then, I am Adrenaline the Bazooka Prophet, a passionate chemistry tutor with over a decade of teaching experience in chemistry, BSc, MSc, and PhD also in chemistry. Now, we are going to be talking about the outlines, and the outlines are as follows. And this is a series of videos we'll be doing in this particular topic, doing justice to it. It is very simple. I can tell you that for free. Now, we'll start with the definition. What is the definition of chemical kinetics? Chemical kinetics can be defined as a branch of physical chemistry which deals with the study of three major things. One, the rate of chemical reaction. Two, the factors affecting the rate of chemical reactions. Lastly, the mechanisms or the series of steps by which this reaction can occur. And as such, those points are the anchor point or the aim by which we study chemical kinetics. I recall the aim by which we study chemical kinetics as follows. One, the rate of chemical reaction. Two, the factors. Lastly, the mechanism by which this reaction can occur. Or simply put, we can define chemical kinetics as how fast or slow a chemical reaction can occur. But then we should understand some basic points here. We'll start from what then is the rate of chemical reaction? Simple. The rate of chemical reaction can be defined as the change in the concentration of reactant consumed. That word consumed. Reactants are consumed, or reactants are disappearing, or reactants are depleting, or the product formed. Products are formed, or products are reappearing, or they are appearing over time. In short, we can simply say that the rate R can simply be defined as the what now change in the concentration of reactants over time, or the change in the product formed over what now time. This is just the backdrop. And as such, the unit of the rate of chemical reaction will be mole per dm cube per seconds. Or this thing here means molar concentration, which is molar concentration per seconds. And we therefore tend to continue under this aspect. Now, we should understand that the rate of a chemical reaction generally, I will speak generally, it is greatest at the beginning, but decreases with time. For example, if you buy a bottle of water, at that beginning, when the time has not started counting, right? It is zero, it is filled up. But as soon as time starts counting and you are drinking the water, there will be a reduction. That's why I say that the rate of a chemical reaction generally decreases with time. And that will take us to another important area in dishing out this graph interpretation, which is what we are to actually talk about in this process. Please Take note. Take note of this point. Very, very important. Now, look at it here. You see this particular graph here now? Rate over time. Anytime you see a graph like this, just take note. Under this part, products, they are always formed. Meaning, as the rate of a reaction is increasing, the time is also increased when products are formed. But in the case of the reactant here, as the rate of reaction, you see it now, there is a decrease in the rate of the reactant consumed. Now, it is these two that explain what we talk about here. Take note, we are given a question, this is what you are focused on. The product formed, reactant consumed. And this is a very important question that we have here on the board. Now, the question says, this is a chemical reaction given to you, ACl, calcium carbonate, we have calcium chloride, H2O, and what you have here. Now, the question says, from the reaction above, which of the following curves represent the consumption? When you hear of the word consumed, it simply tells you that it is reactant. Consumption of calcium carbonate as dilute ACl is added to it. Now, look at what you are giving here to use to explain it. This is rate over time. Of course, what do? You redraw it again like this. You redraw it again like this. Rate over the time. Rate over the time. What? You're only picking two things here. You're picking that of the M and that of the what now? O. Simple. That of the M, product form. That of the O, reactant what now? Consumed. Which is here, which is M. It means that the rest are not important to us. Meaning this one, N, is not part of it. P is not part of it. This is, and you are aware, for reactant here, we're only having ACl, we're having what now? Cacotiri. And we are having for product here, we're having calcium chloride, we're having H2O, and we have what now? CO2. So it means that anyone that are here are formed. Anyone that are here are what now? Consumed. So the correct answer here should be O. So O is the answer, and that is how easy this question is. Now, in our next video, we'll be talking about the disappearance of reactants and appearance of product, how to write the stoichiometry of such reaction. Do well to comment, like, and share. And remain my humble self, Adrenaline, the Bazooka Prophet. Thank you, and God bless you.